Does moving from a 32-bit to a 128-bit addressing system sound scary? Yes. After learning and using IP version 4 for so long, the thought of adapting to IP version 6 used to give me creeps. And if you're preparing for CCNA certification, I'm sure it is one of the most challenging topics as well. But not anymore. If IP version 4 works just fine, then why should we even use IP version 6? And that's what I want to start this video with, the need for IP version 6 and its key benefits that make it better compared to IP version 4. We will then be discussing how the internet works as of now, with a mix of both IP version 4 and version 6 networks in it. I will then introduce to you the Ipv6 addressing structure and the two rules used to compress long and complex Ipv6 addresses. And I will finally end this video by giving away the questions related to these topics, questions that may show up on the actual CCNA certification exam. So let's get started. Why do we need IP version 6? The main reason for this required transition is IPv4 address space is exhausted. Let me explain. IP address space is globally managed and assigned by INA to the regional internet registries, which then further distribute the IP addresses to the ISPs and the end users. IPv4 addresses got exhausted at INA level by 2011 and at regional internet registries level by 2014. And very soon the ISPs will not have any more IPv4 addresses to give out to the end users. Now let's discuss some key benefits of IP version 6. IPv6 offers a large pool of 340 decillion addresses. Yes, it's true. And I had the same expression when I heard this number for the first time. So I'm sure we're not going to run out of IPv6 addresses any sooner. Back in early 90s, IPv4 address space was depleting quickly. And as a result, NAT came into existence. A workaround that helps to preserve internet routable IP version 4 addresses. But it adds delay in the network traffic flow. In IPv6, with so many addresses available, every machine on the network can have its own internet routable IP, which is why NAT is not required anymore, and that results in better performance compared to IPv4. Encryption and integrity checking used in current VPNs is a standard component in IP version 6. Improved security in IPv6 renders man-in-the-middle attacks, poisoning attacks, and other name-based attacks more difficult to execute. All of these features in IPv6 sound exciting. And for your information, the world Ipv6 launch began on 6 June 2012. But the transition from IP version 4 to IP version 6 is still in progress. Today's internet comprises a mix of IP version 4 and version 6 networks. There are several transition techniques that assist in the working of the internet, and these techniques will stay in existence till this transition is finally complete. Let's briefly discuss the three most common transition techniques: dual stack, 6-to-4 tunneling, and NAT 6.4. Dual stack is the ability to support IPv4 and v6 at the same time. All modern network equipment is generally dual stack in nature. 6-to-4 tunneling enables encapsulation of IPv6 packets into IP version 4 for transport across an IP version 4 network. NAT 6.4 is a transition technique that translates IPv6 addresses into IPv4 and IPv4 to IPv6 addresses. It's time to look at the IP version 6 address structure. IPv6 address is made up of 32 hexadecimal numbers. Hexadecimal number system goes from 0 to F, where 10 to 15 are A, B, C, D, E, and F respectively. Every hexadecimal number is represented in 4 bits, and that gives us a total of 128 bits. A group of 4 hexadecimal numbers is called a hextet. There are a total of 8 hextets in an IPv6 address, and each hextet can be represented in 16 binary bits. IPv6 addresses are really long and hence quite difficult to remember and type. Thankfully, these addresses can be compressed in some cases. There are 2 rules for compressing IPv6 addresses. Rule number 1, omitting leading zeros. As you can see in this given example, single leading zeros in second and the 8th hextet. Also 3 leading zeros in 3rd, 5th, 6th and the 7th hextets can be omitted in this address. Rule number 2. Use of double colons. One or more hextets of all zeros can be replaced by a double colon. But remember, a double colon can only be used once in an IPv6 address. As promised, I'll now take you through the Ccna certification exam questions related to the topics we've just covered. The questions are now flashing on your screen, and here's how I recommend approaching them. Write down your answers and then check them against the answer file. Link to the answer file can be found in the description section. Watch the video again till you get all your answers right, and then move to the next video, IPv6 Concepts Part 2. Please feel free to ask any questions in the comment section, and if you'd like to see more of our videos, do not forget to like and subscribe our channel. My name is Pratik. I hope this has been informative for you, and I'd like to thank you for viewing.